Lesson 2.8, Literal Equations. In terms of definition, a literal equation is a formula or equation that involves several variables. This is called a literal equation. In order to solve a literal equation, you will want to isolate the indicated variable to one side of the equation and all other terms to the other. And you will do this using inverse operations. Let me add that to your notes. Using inverse operations. Okay. Please write down number 1. 4m minus 3n equals 8. That's our equation. And this problem wants us to solve for variable m. So I'm going to highlight m in my variable so that I keep my eye on m, because that's the variable that I want to isolate. Okay, so I'm going to look at my equation and I realize that 4 is multiplying m and 3n is being subtracted. So the first thing I have to undo is this minus 3n, and the inverse operation is plus 3n. Whatever I do on one side of the equal sign, I must do on the other. So I'm going to add 3n there. So minus 3n plus 3n, we know, cancel each other out. 4m is what remains, and 8 plus 3n, we know that those are not like terms, so I can't combine them, so I'll bring it down as an expression. 8 plus 3n. Okay, just reminding myself that I'm solving for m, and I'm going to highlight the m to just show you that that's the variable we want to isolate. So in order to get m alone now, I need to divide by 4 and divide by 4. And here the 4's cancel out and I'm left with this expression. M equals 8 plus 3n over 4. And that is my answer. There's nothing else that I can simplify on the right-hand side of that equation, and the variable that was indicated is alone on one side of the equation. Okay, let's go ahead and work on number 2. Okay, number 2. 15 equals 3n plus 6p. 15 equals 3n plus 6p. And I'm solving this equation for n. So let me just highlight n so that we keep our eye on that variable, since that's the one we want to isolate. All right, so on the right-hand side of this equation, I notice that n is being multiplied by 3 and 6p is being added. So to start using inverse operations to isolate n, my first step is to subtract 6p from there, and whatever I do to one side, of course I do to the other. So on the right-hand side, positive 6p and minus 6p cancel each other out, and I'm going to bring 3n down. And on the left-hand side, 15 minus 6p, I cannot simplify. 15 is a constant, negative 6p is a variable term. They're not like terms, so I cannot combine them. So I will write it as an expression. Okay, so just remind yourself that we're isolating n here, okay? So in order to isolate n, I need to divide by 3 on one side. Whatever I do to one side of the equation, I have to do to the other side of the equation. Okay, so here's my answer. 15 minus 6p over 3 is equal to n. Okay, let's go on. Okay. Number 3. Please copy it down. K minus 2 divided by 5 is equal to 11J. And this equation, we want to solve for K. So let me highlight K so that you see the variable we want to isolate. Notice with me that K is part of an expression that is in the numerator. So my first inverse operation is to get rid of that division bar and get rid of the 5 that's dividing the expression. So I will bring this down. K minus 2 over 5 equals 11J. And I will multiply by 5 over 1 on both sides. Of course, when I multiply by 5 over 1, on the left, I'm left with K minus 2 equals, and 11J times 5 is 55J. All right, so just remind yourself we're isolating K here. So let's add 2. Whatever I do on one side, I do on the other. And so K equals 55J plus 2. And again, the reason I have to write it as an expression is because 55J is a variable term, 2 is a constant term, and you cannot combine those. Okay? Here we go. Number 4, copy it down. 28 equals T times R plus 4, and we're solving for T. Let me highlight T so you see it. So what is being done to T? In this case, T is being multiplied by an expression, R plus 4. So let's divide by that expression. And whatever we do on one side, let's do on the other. Okay, and T is isolated. So 28 over R plus 4 is equal to T. And that would be the solution. Okay. All right, let's look at number 5 now. Number 5. 3x plus 2y equals xz plus 5. And here we're solving for x. Well, here we have a bit of a different situation because we have 2 terms that contain the variable x. And recall with me that what you want to do is you want to isolate x on one side of my equal sign. Okay, so in this problem, let's first remove one of the x terms from one of the sides of the equal sign. I think that what I'll do is just remove by subtracting xz from the right, and whatever I do on one side, I need to do to the other. So I'll write it this way. 3x minus xz plus 2y is equal to 5. Okay. All right, the next thing that we'll do is subtract the 2y from both sides. And so I have 3x minus xz is equal to 5 minus 2y. Okay, now what I want to do is factor out an x. Rewrite this as follows. X times 3 minus z is equal to 5 minus 2y. It's the opposite of distributing that x. And finally, in order to get x alone, I'm going to divide by 3 minus z on one side. Whatever I do on one side, I'll do to the other. therefore isolating x. So x equals 5 minus 2y over 3 minus z. Okay, so here are some formulas. Here's the formula for circumference. Circumference equals 2 pi r. And on this one, we want to isolate r, or solve for r. Okay, so if I look on the right side of this equation, I see that r is being multiplied by 2 pi. So let's divide by 2 pi, divide by 2 pi. And so I get c over 2 pi is equal to r. Okay, try number 7 on your own. Okay, check your answer. Volume divided by length times height equals the width. Okay, so let's define the term dimensional analysis. Dimensional analysis is the process of carrying units throughout a series of computations. Number 8. A car travels 100 feet in about 2.8 seconds. What is the velocity of the car in miles per hour? Okay, so what we want to do is we want to take 100 feet in 2.8 seconds, and we want to convert that to miles per hour. So we want to change feet to miles and seconds to hours. We have two conversions that we have to work on. Let's first change feet to miles. So we're going to multiply by this conversion factor. 1 mile is 5,280 feet. That will take care of changing feet to miles. And now let's change seconds to hours. 3,600 seconds in 1 hour. Okay, so now what you need to do is we need to carry through the multiplication process, canceling out the units. Feet cancels feet, seconds cancels seconds, miles stays in the numerator, hours in the denominator. And then we can multiply across. So we have 100 times 3,600 is 360,000 miles. And then 2.8 times 5,280 is 14,784. And then we will simplify. And so this car travels 24.4 miles per hour. Okay, so as independent practice today, you will solve the following literal equations: number 1, number 7, and number 14. And go ahead and work on number 1 on this worksheet. Okay, so write down any questions you have. We will talk about literal equations tomorrow. We will continue practicing. Okay, God bless you. Have a great night.